All right, I made it just in time. Robert from Omaha. If money does not grow on trees, why do banks have branches? Oh my goodness. Well, it's Tuesday, and I don't know about you, but I am ready for another IAEI News Live. We've got a lot to talk about. We started feeders during our last call. Hey, Rob, Nihad, there we go. Let's get that. If money does not grow on trees, then why do banks have branches? I love it. Hey, good morning, Eric Hammond. And good morning to you and everybody else. Absolutely. So today is Tuesday, and we're going to continue now in our discussion last week. Happy Thanksgiving, everybody. Eric, thanks for reminding me. Let me just move that up. There you go, buddy. Happy Thanksgiving. So in our discussion last week, we started Article 215, and I think we got to 215.3, if I'm not mistaken, or maybe we were in. We got to 215.3. Protecting a feeder against overcurrent in accordance with Part 1 of Article 240. But we spent a lot of time on what was it? Ampacity, determining the ampacity of a feeder, the continuous currents and non-continuous currents, and et cetera, et cetera. And then we took a bunch of questions. So we got Nihad El Sharif, we've got Eric Hammond, Robert from Omaha. So thanks for joining in. And Steve, good morning, Steve. Yes. The latest innovations on barriers, yes, in 215.15. That's a very good point. And I know I have, I got the language. And also what I think I'll do is, I also have the 2026 edition up here as well. So hopefully we can navigate our way through and talk a little bit about 2026. And I got my book. I got my book. All right. So, and I got my coffee. Hopefully you have your Colombian roast. Steve Cavaleris. How's it going, buddy? Need my spectacles. And this was the sign-in sheet for my West Virginia chapter meeting where we talked about services. 215. Section, Article 215 is where we're going to be in the 2023 code. And it's a relatively short article, but to the point made earlier, 215.15 is new. We're going to read through that language, and then also 215.18. Those are the two big areas. Travis, good morning, and Steve Cavaleris. Hey, Laura, welcome. Glad you are here. Steve, good morning. Looking forward to part 2. I want to hear the latest innovations on barriers. Absolutely. All right, everybody, let's talk. Let's start talking. So, 215. Remember, I think we beat 215.2 to a pulp. 215.3. The only thing I would say on 215.3, 100% rated equipment. I can't remember if I talked about this or not, but when you're dealing with 100% rated, if you took the continuous loads as 100% rated, or at 100%, not 125%, you're back in your way. You've already made the decision that you have 100% rate of equipment. If you're not doing 125% times the continuous. So keep that in mind. And once you make that call, and you select your overcurrent devices, if you screwed it up, if you didn't buy 100% rated equipment, and including your overcurrent device, then you just don't go out and buy a circuit breaker for that application. You've got to think about the enclosure that you're putting it in. So very important piece of the puzzle to consider. So there is an exception for overcurrent protection to not have to be 125% of the continuous load. But again, it has to be 100% rated, and it's not just the breaker. It's the enclosure you're putting it in. All right, I think we did cover that last. I just wanted to restate that for the record. All right, so 215.4 is your feeders with common neutral conductors. You can have 3-wire feeders or 2 sets of 4-wire or 5-wire feeders to leverage a common neutral. Yeah, 100% rated is an assembly. Yep, I would agree. Eric, do enclosures? Oh, we got a question. Do enclosures or buses include listing or indication that... Yes. In fact, Eric, let's do this. Let's do this. Eaton panel boards. Let's go to a catalog. I'm going to go to a catalog that I know well. Fortunately or unfortunately, let's, if I go to Powerline Expert, let me go to a catalog resources, and I'm going to pull up a catalog from a manufacturer. Let's download. I hit download, and I'm going to open Sesame, and here's what I am going to say. Let's do a search. So make this bigger. Ay, caramba. I am going to make this. I don't have an Apple keyboard yet, so I am challenged. It's the wrong one. Hold on. Me and monitor. Let's do this. Me and monitor. I have to turn that one off, or let me turn that back on, and go to my tertiary. There we go. All right, look at that. Okay, so that wasn't as hard as I thought it was going to be. All right, so if I come into this PDF and I'm going to search for 100%, there's one exception to the rule. Both UL, it applies for 100% of its ratings, so that's that. Harmonic currents. Look, all right, so you'll see a note in this here. It says 100% rated circuit breaker, note 3. So not all circuit breakers are 100%. Where is note 3? Here's a... These here have the note 3 next to them, so that tells you which circuit breakers are 100% rated. And then look at this. Now this is the panel board. So this is just a panel board from a manufacturer. And it says right here, 100% rated circuit breaker requires copper bus, not available in type 12, 4, and 4X enclosures. So this manufacturer for this specific model of a panel board tells you it has to have a copper bus and that it's not available in certain types of enclosures. So you have to consider the enclosure along with the overcurrent device. You just don't buy a circuit breaker, stick it in a panel board, and say, okay, now I'm 100% rated. Right off the bat, I can tell you the standards for panel boards. UL 67, which I probably have a copy of as well. No, not probably. I know I have a copy of UL 67. If I go to UL 67, let's open that and take a look at that one. I don't know what edition this is. I'm just going to grab an edition of, well, I had it. UL 67. There she blows, Cupcake Island. All right, whoops. All right, so this is UL 67, and I'm going to type in 100% rated again. 100%. Oh, man. Maybe they use the words. Yeah, they use the words. 100%. Okay, molded case circuit breaker for 100% loading. Main lugs. Let me just search copper bus. Copper bus has 8 hits. That's 1. Copper bus or dummy fuse. Copper bus or tube should be across that. That's fuses. 600 amps or less. Copper bus only is connected for 225 amps or less. I know there's something in here for 100% rated for a copper bus, and I cannot for the life of me find it. But in any case, in somewhere in the standard, there is, maybe it's in UL 489. I'd have to double check UL 489. But in any case, there is, let me search here for Control F. Whoops, I have to hit OK. Crap. Because I don't have the right keyboard. Ooh. Don't send. Because I don't have the right keyboard, I end up clicking the wrong stuff. All right. Sorry for everybody. So let me type in 100%. Okay, let me close that. 100%. 100. There's a 100% calibration test. The tightening torque, 4-pole breakers, 100% calibration, temperature at 100% ratings. The investigation circuit breaker frame size says usually requires a complete testing, 100% calibration, blah, 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 blah. I know it requires a copper bus. And here we go. It's a 100% calibration test. That's not what I'm looking for. There it is. Okay. 100% rated circuit breaker Mark II, 100% rated shall be tested as described. The small here are some of the details. Here are some of the details. It says a 100% rated circuit breaker marked for use at 100% of its rating current shall be tested as specified in the smallest enclosure, so the enclosure size matters, in open air, blah, blah, blah. When tested without an enclosure, the material shall be considered as being affected adversely if temperatures rise greater than those indicated. These are where we take the temperatures. So wire insulation, electrical tape, varnish cloth, etc. So there are requirements around, bottom line, there are requirements around the enclosure and the bus and all of that that you need to make sure that you meet when it comes to 100% rated type of equipment. Oh boy. Good morning, Tom. Look forward to part 2. I've seen circuit breaker catalog pages that clearly state they need to be used with a copper bus. Yeah. Yep, Eric. Hey, Willie Snyder. Hey, happy Tech Tuesday, buddy. Eric Hammond. Sorry, I was trying to find it for you and did what I could. Chapter 9, A1 for A, Article 4 does list UL 67 for panel boards. Absolutely, Laurel. Thank you for that. And you're right, Dawn. It's all about the temperature as all of the listed breakers have to carry 100% of the rating forever in an open air or 40 degrees C ambient. Absolutely. It's about the temperature rise inside of an enclosure, and I would say that's probably the hardest test for any of the assemblies to have to pass. All right, so I'm going to close out my Acrobat and close out that website. All right, so we're back in for diagrams. So if required by the AHJ, a diagram showing feeder details have to be provided prior to the installation of the feeders. Such a diagram has to show the area in square feet of the building or other structure supplied by each feeder, the total calculated load before supplying demand factors, the demand factors used in the calculated load after applying demand factors, and the size and type of conductors to be used. So this is 215.5. I think it's interesting, 215.5, diagrams of feeders. And it says, if required by the AHJ. Have you ever come across an AHJ that would require this? Joseph Violi. How the heck are you, buddy? So, Joseph, I know you're new to the game here, but in 215.5, where has anybody come across, it says, if required by the AHJ, you have to have a diagram showing all of the feeder details and the calculated load, etc., after applying demand factors and all that jazz. So has anybody come across that before? I can honestly say I've not seen an AHJ require that. That's based upon my that much experience, as compared to all of the viewers of this channel. 215.6 is your equipment grounding conductor, where a feeder supplies branch circuits in which equipment grounding conductors are required. When would you not require an equipment grounding conductor? That's another good question. Where a feeder supplies branch circuits in which equipment grounding conductors are required, the feeder shall include or provide an equipment grounding conductor to which the equipment grounding conductors of the branch circuit shall be connected. Where the feeder supplies separate buildings or structures, you have to follow 250.32. So basically, if you think about a system, you have your service and you have all of these feeders, and they supply panel boards or switchboards or whatever it is, industrial control panels. They go on to supply branch circuits. Your equipment grounding conductor has to be continuous. You've got to have that continuous path all the way back to the source. So, yeah, Willie Snyder, I think you're right. That would probably, when you're looking at the diagrams, you're going to have that all done in plan review. But not everybody requires a plan review. Maybe that's when the AHJ may say, look, I need to see a diagram so that they can ensure you meet those requirements. 215.7, ungrounded conductors tapped from grounded systems. Ungrounded conductors tapped from a grounded system. So, two-wire DC circuits and AC circuits of two or more ungrounded conductors shall be permitted to be tapped from the ungrounded conductor of circuits having a grounded neutral conductor. Switching devices in each tap circuit shall have a pole in each ungrounded conductor. So what we're talking about, when we start to tap, we're going to get into the tap rules, right? So the tap rules are going to be play an important part of the rules, and that's in Article 240, specifically your 240. Was that 240.21 at your location in the circuit? So that's where you're going to find. So that's where you're going to find 240.21 is where you're going to find your feeder taps and the requirements around a feeder tap. So you have your rules for taps not over so many feet long. You got 10 foot, you got 25 foot, and then you have your transformer tap supplying a transformer, etc. So what you have in 215 is the permission to tap a feeder and which feeders you're allowed to tap, and then And then once you do that tap, now you're into Article 240 for where the overcurrent protection is in regards to that tapped conductor and what are the rules around that. So 240.21 is going to be your reference there. But 215.7 is your permission to tap those. And Freddie B. And then the AHJ will compare the plan as to install. That's right. So you're going to need your plans. So, but again, I don't know, but I know there are jurisdictions that do not do a plan review. And I have seen buildings put together on the back of a napkin. So been there, done that. And I don't even know how you compare that napkin to an as-built, but, I'm sure they probably do. Grounding will be electrically continuous. Yes. So you want your grounding to be electrically continuous all the way back. And that's you have to have an effective ground fault current path. All right, we're moving along. We're into 215.9. I like this. 215.9. 215.9. This tells you that, okay, if this is an interesting one, because I had this debate with a home inspector one time. I was selling a house, and my wife calls me. I'm on the road, and she says the home inspector is going to fail us because we did not have GFCI receptacles in the kitchen, nor did we have GFCI receptacles in the bathroom. So I told her, I said, well, tell him to go down the basement because all of the GFCI protection was in the circuit breaker, and I'm protecting all of my circuits. And he said, no, the code requires it to be in the receptacle. So I explained to him that as long as I have GFCI protection upstream, I'm protected all the ways downstream. And he could put his indicator, press a button, and trip that circuit breaker. Well, in 215.9 to be exact, 215.9 says, look, hey, you can put the listed GFCI in a readily accessible location and protect the feeder, which then protects all of the branch circuits that feeder supplies. And that still helps you meet the requirements, or is permitted to meet the requirements in 210.8 and 590.6. Now, I did not have the heart to even whip that one out on him. But after a dialogue with him one-on-one, we came to an agreement that, he would accept a circuit breaker GFCI protecting all of the receptacles on that circuit as meeting the requirements in 210.8. Needless to say, and I could have gone back and said, well, show me in the 19, whatever, I forget what year that house was built, and I know it was before GFCIs were required. It was 1950 something. So there were no requirements for GFCI in that circuit. I didn't even want to go there because I GFCI protected everything. But in any case, you go upstream and you can provide that GFCI protection, and it can replace that requirement. Hey, Lou Petrucci, thank you for joining in. Really appreciate your joining in and helping out with the dialogue here. Well, Don Ganir says 215.9 would let you install a GFCI main to cover all of the requirements of 210.8. Absolutely. Now, so Don, this is the challenge with putting any level of ground fault protection up there at the main. And I know we have 230.95 that is a GFPE requirement, but it presents the same challenges. When you have a problem, if you're trying to solve a problem in a branch circuit, you put the GFCI or GFPE at the beginning of that branch circuit, or as close to where your problem is. And the reason is because when that goes out, you're limiting the outage in the system. And you might say, well, that's because that will give a better reliability. Well, it would, but it's even easier. It's even more important to make the life of the individual who has to re-energize the circuit. Because what does OSHA tell us? OSHA tells us we cannot energize the circuit until we've cleared the problem. And if I have GFCI or GFPE up there at the service and it trips, and the problem isn't right there in that equipment, now it's somewhere else in the power distribution system, and I just can't re-energize until I find the problem and isolate it. Because you could kill somebody. You could burn the house down. You could do a lot of different things that are ungood. Technical term, ungood. So in any case, there is a provision here in 215.9 that would let us put GFCI further up in the system. And then we have 215.10. So 215.10 is it says each feeder disconnect rated 1,000 amps or more and installed on solidly grounded Y electrical systems of more than 150 volts to ground, but not exceeding 1,000 volts phase to phase, have to be provided with ground fault protection of equipment. There is an informational note, and there are 3 exceptions. It doesn't apply to a disconnecting means for a continuous industrial process where a non-orderly shutdown can introduce an additional or increased hazards. Exception number 2 is the section is not applicable if ground fault protection of equipment is provided on the supply side of the feeder. So if I have a feeder that's 1,000 amps, I'm probably got a feeder or a service device that is a higher rated ampere rating, and that's going to be required to have GFPE per 230.95, so I wouldn't put it here for 215.10. And then it says, if temporary feeder conductors are used to connect a generator to a facility or repair, maintenance, emergencies, blah, 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 and you have a 90-day, don't ask me where the 90 days came from, but you have a 90-day grace period for while you're doing the work. So that's, my eye's twitching. That's what that's all about. Robert says, see 215.12C2, 215.12. Identification C2. I'm not sure what that's response to, Robert. That's 215.9. For PV system components in conjunction with Article 690. All right. Yep, we haven't gotten there, but 215.12C2. 215.12 is identification, and C is identification of ungrounded conductors, and 2 is feeders supplied from direct current systems. Well, okay. That brings a whole nother nightmare of stuff. Because as we know, in 690, there are no feeders. Robert, when they redefined, oh man, this is another good one. What did Panel 4 do? The Panel 4 basically said, no, this doesn't apply to Article 690 because they call them power source conductors or DC conductor, whatever they call them. It's not a feeder. So, I don't know. I don't know what to tell you. I would say that 215, this would apply, and this marking would apply, but no, it doesn't apply because 690, if I go back to 690, what does 690 say? This is why creating your own terms and redefining the system is ungood. But, that's never stopped Panel 4. So what they did is in 690.4 or in Article 690, I'm trying to see where they have the diagram. Overcurrent protection. PV system DC circuits. A single overcurrent device where required shall be permitted to protect the PV modules, DC for the overcurrent devices, transformers. Oh, man. That's in transformers. I'd have to look at, we can do a whole nother section on this, but I would argue, Robert, that I would argue that they have a PV source circuit. They've defined it as a PV source circuit. That's what they did. They defined it as a PV source circuit. PV string circuits and PV source circuits. They'll tell you those are not feeders. Although I disagree. They meet the definition of a feeder to a T, but they don't call them that. They call them PV source circuits and PV string circuits. So the question would be, if they're not a feeder, then I would not be following that reference that you made. I don't know, Robert. They didn't add clarity when they created a new terms. All right, so let's keep going. It's 3:32 or 12:32. All right, so I was not at 12. We jumped ahead. So we did 215.10, that's your GFPE, 215.11, circuits derived from auto transformers. Feeders shall not be derived from auto transformers unless the system supplied has a grounded conductor that is electrically connected to a grounded conductor of the system supplying the auto transformer. And there are two exceptions to that. These are identifications of feeders. So the grounded conductor of a feeder shall be identified in accordance with 200.6. Continuous white outer finish, a continuous gray outer finish, 3 continuous white or gray stripes along the conductor's entire length. So 250.6 gives you a means of identifying grounded conductors, and A is 6 or smaller, B is 4 or larger. And then you've got C as flexible cords, D is grounded conductors of different nominal voltage systems, E is your grounded conductors from multi-conductor cables. So you've got a good smorgasbord of identifying the grounded conductor. The equipment grounding conductor in a feeder has to be identified by 250.119. That is titled Identification of Wire Type Equipment Grounding Conductors. You have your general requirements, you have your conductors that are 4 and larger, and then you have multi-conductor cables and flexible cords, blah, blah, blah. So, and then C is your identification of your ungrounded conductors. Those are your phase conductors. You've got feeders supplied from more than one nominal voltage system, feeders that are supplied from direct current systems, and then so that's your, so 215.12 are all of your identification requirements. And you could probably spend a day. I think the best way to talk about that would be to actually see images. I mean, I'm a pictures person. I'm a hands-on pictures person, so that would help me. I know that. So you may feel the same. I don't know. All right, so now we're into 215.15. So let's do this. Copy. 215.15 talks about barriers. So what the code, there was I do not have my pencil. I lost my pencil. I was going to draw. And I lost my pen. Oh, no, there it is. Found it. There it is. Yep, it works. All right. I'm like, I lost my pencil. All right, so let me change this to black and apply. All right, so I should be able to do paste. Paste. select all. And how do I change the color of that? I do that. There it is. All right, and then I can change the font to 2. I can make it larger. There we go. All right, so here is the language. Barriers have to be placed. No energized, uninsulated, ungrounded busbar or terminals exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations in panel boards, switchboards, switchgear, or motor control centers supplied by feeder taps or transformer secondary conductors. Now, what this section is basically recognizing is that when I have, say, a transformer that feeds a panel board, and anytime a transformer feeds a panel board, you have to have a circuit breaker as the main in that panel board, or a circuit breaker just ahead of it. But it has to be on the load side of the transformer. So if I drew this and said, this was my panel board, and we'll do a style and we'll make it dashed. Okay, so if this is our panel board, that's a panel, that's a transformer secondary, this is a delta Y ground, and then I have a breaker upstream. So this is my transformer secondary conductor. That's a feeder. That's an Article 215. This transformer secondary, this is going to be a 240.21. What's the section? 240. I hope I got the right one. 21. Yep. 240.21. Is it? It's not B. It's C. 240.21 Charlie. Okay, so that's the rules in 240.21C, which transformer secondary conductors, they're not these for a delta Y ground transformer. Those conductors are not protected by the primary overcurrent device, and this would be 408. I know we're getting a little beyond 408. I got to go to panel boards, which is part 3, 408.36. 408.36 is going to tell me that, in fact, 408.36b is going to tell me that for a panel board supplied on the secondary of a transformer, you have to have the overcurrent protective device, which is that for that panel board located on the secondary of the transformer. All right, man, I got to go back. I'm looking at what I'm missing. I got Lou. There we go. Where is selective coordination GFCI protection in main? In a main, in lieu of the branch circuits. Where is the selective coordination GFCI protecting a main in lieu of branch circuits? I'm not sure I understand that question. You have selective coordination requirements in 700, 701, 708, and in a few other areas, not in healthcare. 517 does not have selective coordination requirement. But that's the challenge. That is a challenge. That is a challenge for us. Very few places where selective coordination is required, David, exactly. Very few. That's Don Kinnear. Laurel, 215.10 was 600 volts, 2020, and now it's, it's 1,000 volts. I agree. Boy, I was missing. There has been ongoing progress to replacing 600 volts, with 1,000 volts AC, and I got to make this smaller. Sorry, guys. 1,000 volts AC and 1,000 volt and 1,500 volts DC. Yep. Panel 4 would prefer that 690 be like Chapter 8. You're absolutely right, Dawn. 240.2. But you know what's funny is they don't understand feeder protection. So there's a lot of things that the Panel 4 guys and gals don't understand about certain things. And anyway, I'm not going to get into that. Panel 4 would prefer. Yep. So 240.21C. Thank you, Dawn. 408.36. Yep. We already talked about that. 408.36b specifically. What about your integrated? Yeah, so Robert, if you have a circuit breaker integrated with the transformer, those are no longer transformer secondary conductors. That's a feeder. So now I can go to any distance and all that jazz. So the way this code is written, barriers shall be placed supplied by feeder taps or transformer secondary conductors, right? So a transformer secondary conductor is going to be a defined term in the 2026 code, and a transformer secondary conductor, if I have a transformer and I come to a breaker, and let's say that this is all one unit. Okay, this is all listed as a transformer with a secondary OCPD. Okay, the transformer secondary conductor, that's the transformer secondary conductor. It would also be the transformer secondary conductor if I did that. And I had the breaker outside of the transformer. The transformer secondary conductor is longer, and it extends beyond the enclosure and goes into a panel board, a switchboard, switchgear, whatever that first piece of equipment is. So the way the language reads, that if you feed a panel board, a motor control center, switchboard, or switchgear, any of those devices, by a transformer secondary conductor or a feeder tap, and we'll talk about that, then you need to put a barrier, and the barrier would be placed right on the line side of that main conductor, breaker. And we do the same thing in services, right? We do the exact same thing in services. So, and that's where you would need the barriers. So transformers with integral breakers would need barriers on the line side of the circuit breaker. I would agree with you, Eric. That would be governed though by the standard. So now remember, if you have a transformer that is a listed assembly that comes shipped with a secondary breaker integrated, then you have a listed product. You're not going to open that product and look for X, Y, and Z inside there based on the code because it's a listed assembly. The only time you start picking apart the internals of that enclosure of that listed product is when you see something that has been modified or changed. But Eric, I would say if there needs to be a barrier as part of that listed assembly, that would have to be driven by the standard product standard. Now, that product standard change could be influenced by this code requirement, But you would not take that listed product apart and apply the code. Yes, Laurel, like and subscribe. Don't forget, please. Thank you. And become an IAEI member if you are watching this and you are not. Thank you very much, Laurel. I can always count on you for that. All right, so the barrier would be placed in here. Now, the other condition is if I have a feeder tap. So let's say that I have this scenario, and I tap in, and I come down, and let's say that this is a feeder of, I don't know, X size, and this is a tap of Y size, and Y is less than X. Okay, so now, and I feed a panel board. So now I have a tap conductor that is of a smaller size. I have the breaker that is inflated in size. So I would require this to have a barrier. I would go back to the list. Anywhere where you have a panel board, switchboard, switchgear, or motor control center supplied by a feeder tap, feeder taps, or transformer secondary conductors. We just talked about transformer secondary conductors. Now we're talking feeder taps. And the reason is I have risk. Risk is comprised of likelihood and severity. So in this case, my severity is high because incident energy is going to be higher here because the protecting overcurrent device, which is this feeder, is inflated in size. You add this conductor length, that conductor length, my arcing currents are going to be lower. I'm not going to be into the, I have a high likelihood of not being in the instantaneous region of my protecting overcurrent device. So I have to think about the higher severity in those applications. Very similar to your service entrance conductors, which will have the utility transformer. You have unprotected conductors landing in a panel board, and we have barrier requirements there. So very similar application. Michael Hofkin in the house. Yes, Eric Hammond. Yes, very similar to barriers for meter stacks and for service equipment, all service equipment in Oracle 230. You may be late, but you're worth the wait. Michael Hofkin in the house. Thanks for joining, Michael. All right, so let's go back. So 215.15 is a new barrier requirement as part of NEC 2023. Trying to think if there's anything else in 215.15 very similar to our service barrier requirements in Article 230. He is humbled. Michael, I don't think you can be humbled, buddy. Come on. Now, let's talk surge. Ryan Jackson, you just joined in the nick of time. I got 10 minutes, and I'm going to hit surge. So here's what they did in the 2023 cycle. In fact, I think I have an image. So I'm going to throw this up on the screen. And hopefully you have your copy of NFPA link. Let me throw this up. Okay. And so basically the 2020 code made it a requirement. The 2020 let me find IAEI's. The 2020 code introduced dwelling units to have surge requirements. And in 2023, that's transformers. I don't want transformers. I want NEC 2023. Code changes. There we go. Barriers. Look at this. Oh. That's barriers. I don't want barriers. I want surge. We already talked about surge. Control F. And search for surge. Whoops. Sorry about that. Surge. Here we go. All right. Yes. All right. Here we go. I got to make sure that I am seeing what I'm seeing when I see it. Okay. So 215.18 surge protection. There's a new section requires type 1 or type 2 surge protective devices when a service or feeder supplies a dwelling unit, dormitory unit, guest rooms of hotels and motels, and areas of nursing homes, limited care facilities used exclusively as patient sleeping rooms. The justification that was used, and I'm going to tell you, and I think a lot of people make the mistake here. They say the reason you have surge is because you have surge requirements is because AFCIs and GFCIs and smoke detectors need to be protected. That's a good reason, but it's not the whole story. Remember, the code is not just about protecting personnel. The code is about also protecting equipment. So if I have a device like a surge protective device, and I can show that I will prevent the damage of electronics and multi-millions of dollars worth of household appliances, that's a good reason for a code change. I don't need to translate that to say it's going to save a life. If you look at Article 90, it's about protecting personnel and property. It's not just about protecting personnel. So when we first went down this surge avenue, we were talking to a very major insurance company who the figures of loss due to surge across the United States was absolutely, in fact, I did not know the numbers were that high. They could not provide that data because it's just like what the payout is on loss for an insurance company is very similar to if you asked a manufacturer, how much money do you make, or how many of any product do you sell on an annual basis. That would be confidential information. We navigate those waters to try to figure out who has market share and all that jazz, but that wouldn't be something that, if I went to a manufacturer of, I don't know, computers and said, if I went to Apple and said, I want to know exactly how many Apple MacBook Pros do you sell and how many iPads do you sell, that would be a market information that if I was a Microsoft person or a person who was competing with them, I could use against them. So in any case, the insurance companies were the same way. So we couldn't get that data. NFPA Research Foundation did some homework. they came up with some good information. So then we had a requirement for surge. And then we expanded in the 2023 cycle to require surge in these new locations other than just a dwelling unit. So I think I can do this. No, I can't do that. I got to click over there. So a type 1 or type 2 SPD is permitted, and that's in 215.18c. You can have a type 1 or type 2. A type 1 can be placed on the line or load side of the service over current device. A type 2 can only be placed on the load side of the service over current device. Then you have the location is in 210.8b. These are the just different types of devices. Again, how it's installed. There's a nice image. So now the location is the SPD shall be installed in or adjacent to the distribution equipment connected to the load side of the feeder. And then we also talked about this the type as well. So now this is an image that I know I'm showing the language of 230, but 215 is the same. Except for the exception in B, there's just an informational note in 215. But I throw this diagram up because this was I get this question a lot recently. I think just because I started talking about it. But we had a project, for example, that I saw where we had this exact sort of a one-line diagram. You had your service equipment, which was say, a large switchboard. Off of the switchboard, they went and they fed some panels for common areas, for lighting and for mechanical, like your HVAC, your chiller, or whatever. So they came off of that service equipment. They fed those two. I call it an L1 for lighting and an M1 for mechanical. The L1 and M1 did not have a requirement for surge, so there was no surge in those two pieces of equipment. The meter center is at the end of a feeder. On the secondary of that meter center are feeders that go to panel boards in each of the dwelling units. If I'm in the service equipment, I'm following Article 230, so there's the language that I would be required to follow. And it says all services supplying the following occupancies, and that service supplies the dwelling unit occupancies that are down there on the bottom. So that service would need to have an SPD, which is indicated there. Now there's an exception for the location. It says the SPD shall not be required to be located at the service equipment if located at each next level distribution equipment downstream toward the load. Well, the meter center is downstream towards the load. The dwelling unit panel boards are downstream towards the load, but so is L1 and M1. Now, L1 and M1 was not supplied with a surge protective device because it wasn't required by code. Because they didn't serve the dwelling unit, the dormitory unit, guest rooms, or guest suites. They supplied common areas for mechanical, HVAC, etc. So they didn't put a surge product in L1 and M1, and those two would be included at each distribution service equipment is each next level distribution equipment downstream towards the load. So those L1 and M1 did not have surge. So what this group did not put a surge protected device in the service equipment, and they did not put surge protected device in the meter center. They only put surge at each of the dwelling units, which violates two sections, in two different articles. 230 would require surge in the service equipment because the L1 and M1 panel does not have surge. If they put surge in L1 and M1, which probably would have been easier, I don't know, then you wouldn't need it in service equipment if you also had it in the meter center. So now the meter center is not covered by Article 230 because that's not service equipment. The meter center is actually a feeder equipment at the end of a feeder. So the rules that you would follow for that feeder that supplies the meter center is in 215, and it says where a feeder supplies any of the following, a surge protected device shall be installed. So if that feeder that feeds the meter center supplies a dwelling unit, which it does, and I had to call a few inspectors on this one, and I remember Donnie Cook telling me, he says, Thomas, if you remove that feeder, do those dwelling units get power? And I said, no. He goes, well, then that feeder supplies the dwelling units. I'm like, man, okay. So that meter center would be required based on 215 to include surge, as well as each of those dwelling unit panels, based upon the language. So that's basically how that reads. I hope that sort of makes sense. But and I think that's missed a lot. I think that a lot of inspectors would just go down to the dwelling unit and say, okay, you got surge at the dwelling unit, and then I'm not going to worry about the meter center or the service equipment, or those lighting panels, or that mechanical panel. And honestly, I can't say whether or not that's okay or not. I can just tell you that that would be a code violation. Going back, great point, Tom. Article 90, people and property, absolutely. Everybody seems to forget that the code can protect property as well. I don't have to save a life. The exception is terrible. What exactly is distribution equipment? A fuse disconnect? Yes. I would say a fuse disconnect is distribution equipment. But very good. I don't disagree with you. Ryan, I don't think we have any definitions for distribute. Now, let's see. Do we use that term? Let's see if we use distribution equipment. Distribution equipment. I'm going to look in the National Electrical Code. So we do. Wow. We use the term distribution equipment in 708.11a, and if we don't know what distribution equipment is, then how do we use the term in 708 in Article 708 feeder distribution equipment for COPS feeder circuits, including transfer equipment, transformers? So let's take a look at this. Feeder equipment. Feeder distribution equipment. That's the name of the entire section. Equipment for COPS feeder circuits, including transfer equipment, transformers, and panel boards, shall comply with the following. So we use the term feeder distribution or distribution equipment. Location of electrical distribution equipment, 682. Serving feeders. So if we don't know what it means in that exception, then I would argue, Ryan, what are you doing about each one of these is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10, 20, 30, 40, 50, 60, 70, over 70 locations in the code where we use the term. I'm okay with we need to stop using the term distribution equipment. There are enough defined terms that we can use defined terms. I don't disagree with you. I look forward to your public input. Steve, electronics are being integrated with power systems in dwellings, and commercial devices with electronics and computers are everywhere. SPDs will be even more important with time. I agree with you. And here's the other thing, Steve. We're talking about surge protection on the power components. What about surge protection of telephone wires, cable, and other data communications? We don't have requirements for those. And I know if I go back in time, I'll tell you how long ago this was. I mean, if you just do the math, I had a DVR. I had not a DVR. I had a VHS recording machine. I had a telephone that was like one of those wireless telephones, and a television. The VHS should give you a little indication of how long ago that was. But I had just put in a surge from a manufacturer who had a warranty that said, if you put surge on your service equipment, if you lose equipment in your home due to surge, they would cover the cost that the insurance company does not cover, so you're deductible. Well, when I lost my TV and my VCR, that's what it was, a VCR. I lost my VCR, I lost my TV and telephone. I took my TV and my VCR into work, and I took it to the lab, and I told those guys, I said, first I said, you guys owe me. I think my deductible was $500, which the insurance company, I didn't even reach $500 and everything. That shows you how much money I spent on TVs and VCRs. But they took it apart, and they said, and they showed me on the board, the surge damage did not come from the power supply. It came from the cable that came into the VCR. Gosh, I can't remember the acronym anymore. The VCR, it came from the cable and not from the power. And also on my television, it came from the cable and not the power. The power circuitry looked great. The board that was burnt was the data cables. So I would argue that we don't have any surge requirements around the data side of things. We cover the power side. Now we do our intersystem bonding jumpers and our intersystem bonding. What is that little bonding for we bond our communications and whatnot? But I don't know. I think I think that's going to be our challenge. And Robert says, wow, looking forward to not API. Unless you did a global, Ryan, you would have to do for distribution equipment. You have over 70 locations, so I look forward to your 70 plus. Let's see, what's on page 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 70. Oh, wait a second. Yeah, 70. 70 public inputs for next cycle. So, all right, everybody. We got through 215. Had some good discussion around the barriers. What was the other item? 100% rated and all that jazz. We have primary protection requirements in Chapter 8. Do you? See, I'm not a Chapter 8 guy. I like it. I love it. I want some more of it. Would that be in Article 800? I'm going to do search, and I'm going to type SURGE. Surge. There it is. Bonding of electrodes. Search. 800.100D. A bonding jumper not smaller than number 6 shall be connected between the grounding electrode and power. That's what I was talking about earlier. But that's the only place I have surge that I can find in Chapter 8, Ryan. But I'd love to know. Primary protector is basically surge protector for communication systems. The primary protector. Excellent. Beautiful. All right, gentlemen, ladies, Steve Cavaleris, Don Gannier, Ryan Jackson, thank you all for joining in another IAEI News Live. Love you all. I appreciate you. And I thank you for what you do for the electrical industry and electrical safety. 805.50 is all about it. All right, so go and I will do your homework. Homework for tonight is to take a look at 805.50. circuits requiring primary protectors, which Mr. Jackson is saying is surge. Take a look at that and brush up on your surge requirement for your data and your communications. Thank you, Steve Cavaleris, Don Gannier, Laurel, Eric Hammond, everybody for contributing. And don't forget to hit the thumbs up, hit that subscribe button, hit the bell too. You'll be notified when we go live. Thanks for all that you guys and gals do for electrical safety and electrical industry. Take care. Please stay healthy. I'm out of here. See you next week. Cheers, Ryan.